My microphone is working. Praise the Lord. With related rates. What are from the examples on Friday? No, let's do an example first. Some of you guys worked on it this weekend. Some of you guys worked on it in the early part of the weekend. Some of you guys worked on it in the latter part of the weekend. I did change the deadline to tomorrow at 7 a.m. True? For the homework? Okay. Why did I do that? Because instead of taking 2-ish full days of review, we're kind of doing an old-fashioned 1 day of review. As a result, your practice test is going to be a little bit shorter. It's going to be posted by the end of the day. Your goal tonight is to finish the related rates homework and, if possible, get through as much of the book review as you can, but the book review won't be due until the day of the test. If I did not change that deadline yet, I will get it changed. So we're going to have the book review be due on Wednesday. It's not specifically up there on the board. I probably should have put it up there, but we'll say that, the Chapter 2B review and test due on Wednesday. That way you guys have a little bit of extra time. But the more you get done for tomorrow, the more after related rates homework questions are done, we'll be able to answer the questions that you've already faced. And then the practice test is going to be shorter because I don't want to give you like this full length, extra huge assignment because you're not going to have like a full day for it. Unless for some reason tomorrow when we reevaluate life, if I do bump the test, once again, it's not to make your Halloween night horrible, or I should say your October 31st night horrible. It's to try to give you extra grace so that you can be more confident and prepared for the test. Sound good? Okay. So let's do an example all together of related rates, and then let me ask some of the questions that I was going to ask after we have some more experience. So, kiddos, when you face a problem for related rates, could you write down the whole paragraph? I suppose, but the point is to summarize. Do you see where that information came from? Do you see where that information, we make it a little bit bigger. Do you, oops, well, I saved it. That's, go team. I apologize. A baseball diamond is a square whose sides are 90 feet long. Suppose that a player running from second to third base has a speed of 30 feet per second at the instant when he or she, look at them being all correct, is 20 feet from third base. At what rate is the player's distance from home plate changing at that instant? Okay. Question. What was the very first step in this problem? What do you guys think? I haven't finished it, but I do have parts of it set up. What can you guys fill in? What can you tell me as to where it is and why? What do you see? Raise a hand if you see something, where it came from, just from the wording. That's totally fine. What do you see? Okay, that is another variation. Why is Ryan saying 90 if the picture doesn't show 90? He's taking Pythagorean theorem. That's true. But are we, remember we have to be super careful. Are we allowed to plug in 90? I think this is what Ryan was doing, was Pythagorean theorem. I'm not sure if you got the minus in the right spot, Ryan, but I'm just writing it down the correct way. I think you did. Why is he plugging in 90, and is it legal? Be careful. If it's not legal, we're going to get in a lot of trouble. Is it legal to plug in 90? Are you guys picturing the guy running from second to third? This is second, right? If you don't know baseball, this is second, this is first. Here's your home. Here's third. All we're talking about is him running from second to third, and then he stops. So as he runs from second to third, what is not changing in regards to this triangle? A is changing and C is changing, but yeah, what's not changing? The distance between third and home. Isn't that staying 90 the whole time as this guy runs? Now, how far away he is from second is changing. How far away he is from third is changing. How far he is away from the home plate is changing, but what's not? And what can we do with unchanging values? Make it constant. Yeah, you can plug it in at the beginning. Do you have to plug it in at the beginning? No, but you can. So Ryan's right, except Ryan jumped like 3 steps over here, which is good. It's not bad. But we can say a squared plus 90 squared is equal to c squared. And Ryan, we could get c squared by itself, or 90 squared by itself, or this, that, and the other by itself. But I'm just going to leave it like that, because with implicit differentiation, we can also just take the derivative as is, right? So either way, either way. But hold on, pause. We should never jump to the formula. It's not a bad idea to see it. It's not even a bad idea to write it down. But we should always start with what? And the fines, and to some extent, to be honest, I would say start with a picture. Because if you didn't have a picture, would you know to call this guy A for D? You guys could have chosen. This could be X and Y and Z. This could be T and B. I don't know. It could be whatever you want it to be. Just a few of you guys would have seen this word distance, and this would have actually thrown you off because you might have gone to the distance formula. Ooh, D equals square root of x2 minus x1 squared plus y2 minus y1 squared, and you would have been in trouble because it's literally saying, no, how far from the player to home? Oh, that's the hypotenuse. Sometimes drawing a picture can make what? Usually. Drawing a picture can make all the difference as far as, number one, you establishing variables that you want to use. Number two, you trying to figure out what's the situation. Oh, hey, there's a right triangle. I bet I can use that. That relates how far the player, wait, how can you define A? What's A talking about? I said how far the player, how can you finish that statement? What's A? At one instant, there's a such that. But how would you finish this statement? What's this talking about? A is defining or showing or signifying how far the player is from third base. Okay, good. Is from third base. And then C could be how far the player is from home plate. And then B is the distance of the baseline from third to home, which, okay, it's always 90, no big deal. So once we have that question, how did I fill in this statement? Speed, good. Speed of what? The player running. And as the player runs, what's changing? At his rate, at how fast he's running, what's changing? How far he is from second and how far he is from third. So why do I have negative 30? Yeah, A is decreasing. Now what if we were talking about another shape and we were up here in this triangle, which we could have done, but there's no right angle. If I do this triangle, and I'd have to use law of cosines. We'd have to use law of cosines because it's not a right triangle. We would call it an oblique triangle from last year, which you could do, but it'd be way nicer, way easier. And we wouldn't have like a set defined side, which we'd be in trouble because we wouldn't have a 90 as a constant. Anyway, so we're using this one, how far he is from third. And it's a nice, pretty right triangle, so we're going to use this one. But as he runs, A is decreasing. And C is decreasing, but we don't know what that is. That's why we're trying to find it, because what's the question say? Is the player's distance from home plate. And what did we define the player's distance from home plate to be? C. So now that we have written down our givens, the such that is when A, wait a minute, A equals 20. Oh, does that make sense? When he or she is 20 feet from third base. What if they had told me when he or she is 70 feet from second plate? Could you guys have also figured out that A is 20? So they can give you clues that don't seem to fit. Oh, they're 70 from second. That's not a part of my picture. Oh, wait, the whole thing is 90. 90 minus 70 is 20. So they could have given you more information if they really, really wanted to confuse you and told you something like, oh, hey, this is going to be 70 at one time too. But that's always changing. It's not constant, so we're not going to label our picture with that because our picture is constantly changing. It's showing movement. Once we have this formula, Ryan helped us out. The 90 squared is plugged in. How do I get from here to here? How do I get from here to here? Take the derivative, right? Just take d dt. Now, what if Ryan hadn't pointed out that clue? And what if we had just gone? Wouldn't we have gotten 2a dA dt plus 2b dB dt equals 2c dC dt? Would that have been a problem? Yeah, because it's like, well, okay, I know A, I know dA dt, I don't know B, I don't know dB, I do know C, wait, I don't know C. Okay, you would have figured out B and you don't sides if we don't have 2? Wouldn't we have been in some trouble? So hopefully that would have sent you back to the problem saying, what did I miss? What did I miss? Oh, 90 feet. What's that? Oh, that's B. Oh! So that we could plug in if we needed to. We could, okay, we know 20. We know dAdt is negative 30. We know B is 90. And then hopefully, your brain would have been like, wait a minute. As that guy runs, is the 90 changing? And hopefully you would have been able to say, oh, that guy's 0. Oh, okay. I guess I didn't ever have to even keep him a variable. I could have just made him a constant. But here's the dilemma, kiddos. The 90 for helped us dB dt is 0, and already pointed out earlier. But here's the dilemma. What are we still missing? Yeah. So either way, we get to this final expression where all we need is 2 and a, which we already know because are such that now we can take our clue, now we can plug in. Remember, disregard the clues if they're not constant, if they're not staying the same. We have 2a dAdt equals 2c dc dt. I don't mind dc dt being unknown. That's the whole point. I want to know who dc dt is, but how do I find c? Oh! Good, Ryan. I don't just have this clue to plug in. I also technically have this relationship that we had to end up using that I can always come back and use and say, oh, hey, when A is 20, I already know what B is. I can find C, right? And C is going to end up equaling the square root of, 8,500? Would you guys agree with that? Something like that? Because 20 squared is 400, true? And 90 squared is 8,100, and 8,100 and 400 is 8,500. Can that simplify? I don't know. I rightly don't even care. So I'm going to come back over here and say C is equal to the square root of 8,500. I mean, you can pull 100. So I could pull out 10 root 85. There we go. End of the day. This is a long answer, couldn't you? I know it's tiny. Someone in the front, can you help us out? What are the units? Now, why does that make sense? What is this measuring? The rate of change of the player's distance from home as he goes from second to third. Oh, hey, what's this? What unit? Feet. And then that's dc. And what's dt measured in? Time or seconds. Good, feet per second. Okay, now let's take a quick timeout. Quick timeout. Related rates. Whew! Whether or not your brain was ready for related rates this morning, at least we've done one now, okay? What's the first step of a related rates problem? Hold on. How do you know it's related rates? I don't know. It's a word problem. Okay, fine. What do you do with any word problem? Yeah. Read it. Figure out what's been given. And if you don't have like variables to make it all nice and pretty, maybe go to a picture and make variables, yeah? Okay? So try to make some sort of like statement of givens and finds, and if you don't have variables yet, okay, fine, make a picture. Try to figure out what's going on. Label sides and whatnot with different variables and quantities. Remember, we can only label a number if that quantity is staying the same the entire time. You have to think about the motion. With the water draining out of the conical, whatever. The container stays the same, but the water, everything's changing. The radius is changing, the height is changing, the volume is changing. We talked about on Friday, Nick, was it you? About the cylinder, right? What would happen if water was in a cylinder? Would the height still be changing if it drained out? Yeah. Would the volume be changing? Yeah, but what wouldn't be changing? The radius. So we can plug in things that don't change, but we have to think about the motion. So as the player ran, this was changing, that was changing, that was changing. Even the angle was changing, but what was not? It saves you a little bit of time if you think about that ahead of time. But if you don't think about it ahead of time, you just go for it. Wait, where did he come from again? We figured out our clues, the given, the find. We figured out a picture. What was this? Same as Pythagorean theorem. And then how did I figure this out? Yeah. about this, and they talked about that, and I know that. That relates to the three Pythagorean theorem. Take a derivative, plug in what you know. If you don't know something, wait, are you going to stress out and freak out and say, it's not there? No, you're going to take and then you're going to say, there's more. Does that make sense? Go back, reconsider, there's more. Now, was this kind of hidden? Yeah, but was it there for the finding? Yeah. They gave you the 20, they gave you the 90, plug and chug, and then you were able to find the C. So even if something seems to be missing, go back, reconsider. There's another clue you haven't considered. Okay? Let's go ahead and see another one. Let me give you guys a second. Even better than that. You guys have seen me do a lot of analysis, and I know some of you guys might have just seen that, and that's totally okay, but I want you guys to take a second. Maybe you saw it and memorized it, you have that kind of mind. But if not, go ahead and read the following and see what you guys can point out or write down or label. Oh, hey. I already kind of helped with the picture. I think the book helps with the picture on this one too. Did anybody get up to the rocket problem? I think there's the picture for the rocket problem. But I want you guys to see, can you write down your given? Can you write down your find? Can you figure out a formula? Because after that, let's just take a derivative and plug and chug. After that, it's just take a derivative and plug and chug. Collaborate in your groups. Oh, we're still trying to do it on our own. Okay, a little bit longer. I don't mind. P.S. I'm covering up the Y. That's okay. That's okay. Maybe some of you can go all the way. It's okay. I labeled one side Y. You could label another one X, another one Z if you want, but you don't need the Z. Ooh, that was a good hint. You don't even technically need the X. Okay, so only this is not. Okay, now collaborate in your groups. You guys have to collaborate at some point, I suppose. The same people that invented sin. Well, not the same people. Same category of people. Do you guys get it? Why is dy dt 880 feet per second? It's the rate of change of the rocket. And the rocket from the ground is what? Y. So as the rocket rises, what changes? Dy dt. Why is it a positive 880 feet per second? Because the rocket is going up. So Y is growing. Does that make sense? Why did I put d theta dt? What wording did I just pull out? How fast how fast is a rate, and then the angle. That's d theta dt. Remember from our forever card or from our notes? Sorry, it wasn't a forever card. Rate of box is d box dt. So if they ask how fast is the angle, d theta dt. If they say how fast is the rocket is y, dy dt. Such that 4,000 feet above the launching pad. But remember, to ignore. Why? Is y changing as the rocket goes up? Yes. So is that constant? No. Okay, good. Ignore that. Ignore that. So guys, what formula relates theta with y? There is no formula. You need a third side. Okay, it's the other side they talk about. A camera mounted at a point 3,000 feet from the base. Wait, where's the camera? It says from the base. Isn't this the base? Isn't this the launching pad? Like right here? Okay, well, where's the camera? Right there. What's staying constant? 3,000. Why? Picture it. There's a rocket going up. Little camera guy's over here. Imagine like an old-timey one, like in the early days, right? It was like running. And then what's the camera doing? The camera is following the rocket, but is it getting closer to the rocket? No. Safe distance, safe distance. What's it doing? It's filming and it's looking up as the rocket goes up. What's not changing? 3,000. So what can I do over here to get me closer to here? How is there a 3,000? Because what did I do? Yeah, I can plug in. That's staying constant. Tangent of theta. X over y. And who over who? Ignore me. I labeled my picture wrong. What should it be? Tangent equals y over x. And then how am I going to plug in? Y. I don't know why I put x over y. Sorry, that was lame. Y over x, right? Opposite over adjacent. If I can say that x is 3,000, that's staying constant. So now what? Derive both sides. And as you derive both sides, you guys okay getting there? Derivative of tangent is secant squared of theta times theta prime dt equals, ooh, what did I do? I rewrote 1 over 3,000 y. But if you didn't like that, maybe you would have gone this way and done quotient rule. Secant squared theta d theta dt equals bottom d top minus top d bottom all over bottom squared. Would you guys have looked back and realized dx dt, right? What should that make you? Is missing and it's not the one that you want. We want this guy. We have that. Imagine the rocket going up and the camera tilting. What's staying the same the whole time? Oh, it's constant. And if it's constant, well, that's just going to be 0. And then I can, then the x is reduced. And x. So then I end up with dy dt over x. Well, who's x? Oh, 3,000. Look, it ends up being the exact same thing, no matter how you go. At the end of the day, what do we now need to do? Just plug and chug. Oh, but has anybody already realized what we're missing? Not that it's a cause to freak out or anything, but has anybody realized what we're missing? dy dt, that's 880. We need to find d theta dt. What are we missing? Theta. When y is 4,000, what's my theta? Hey. If y is 4,000, at an instant, this is like a snapshot in time, and x is 3,000, like always, what must this one be? Isn't it a 3, 4, 5 triangle? Who's theta? I don't know. Tangent 4/3, and those aren't in my unit circle. I don't know 3/5 and 4/5 and, but wait, do I really care about the theta or do I just want the secant, the square? Do I really need the theta or do I just? Why is that so awesome? You don't need a calculator. You don't need to do secant. You don't need to do that. All you need to do is say who's secant. Choshikao, hypotenuse over adjacent. Who's secant of this triangle? Secant is 5/3. Hypotenuse over adjacent, or 1 over cosine, or the reciprocal of cosine, which would be 3/5. Reciprocal is 5/3. You did not need theta. You just needed the ratio. So we end up with a final answer of 880 all over 3,000 times. Have to multiply by the reciprocal, so that would be what? 9/25. And if you were too scared about that, you could make it 3/5 quantity squared. Wait, why are the units radians per second? What's this supposed to be equaling again? D, who, dt? Theta. Theta measured in? Radians. Why not degrees? Because it's calculus. But long story short, radians have to do with the actual measurement around and not just some like pretend measurement in a protractor. Radians occur naturally. Degrees do not. I know that's weird, but we're dealing with lengths and measurements. We're going to be finding angles in terms of radians. Okay? What have we not gotten to? The very last example before you guys tackle homework. Oh, this is so sad. It's like coming in pieces. We're going to do this one all together. Oh no, I didn't really give you guys space, did I? That's okay. I don't think you need a table. I don't think you need a table. I don't even think you need a picture. Let's figure out our given and our find. Don't need a picture, but we will try to figure out our quantity. What's our given? Good. dy dt is equal to 2 units per second. What are we trying to find? dx dt, how fast is x changing? Such that, x equals 2 and y equals 5. Good. And technically, what else are we given? Y equals x cubed plus 17. Y equals x cubed plus 17. Wait, what are we supposed to be? Do you guys have any idea? Wait, we've been given a formula? Do you guys see it? Oh, so what can we do? Take the derivative. And when you take the derivative, are you going to end up with a dy dt on one side and a dx dt with other stuff on the other side? Are you going to solve for one by plugging in the rest? Related rates. Just got to learn to read, translate, derive, plug in, and if you miss any clues, don't freak out. Go back and reconsider. All right, guys, tackle this homework as best you can. Tackle this homework as best you can. Come tomorrow with questions, and we'll see where we're at. Okay, the practice test is at the end of the day, but my advice, if you finish this homework, or if you get as far as you can, pause, skip a couple pages, and go to your test review. Play with that. Get out of here. Sorry, you can go. You can go, you can go.
Are there going to be any moving area problems with like a weird 4/3? I just don't like